All right, good morning, everyone. This is November the 6th, 2020, and we'll be continuing on with our wood lecture. I think last time we had made it up through special use wood, and then we had gone on and we were ready to talk about deterioration of wood, as you can see here. Let me try something else here. Oh, bear with me one second here. All right. Okay, so let's talk about deterioration of wood. Hopefully you can see that okay. So this is a good test question. Wood has four major enemies if you had broad categories. Insects, and we'll talk about some of those. Marine borers, we don't have some problems really with those around here, but we'll mention those and you'll be able to see some of the damage that they can cause. Fungus or a fungi, people say I'm a fungi, and fire. So most of these, as far as protection, we'll look at different chemical treatments, but there are also, physical barriers that we can use. As a general rule, though, when we look at the cross section of a tree, if you remember those layers, the heartwood, which is near the center, not the very center, but near the center, is more resistant to decay than sapwood. It's harder, and remember it's not active in a growth process, but sapwood, because it's it's easier for us to inject, or you might say impregnate, with chemicals, so it can be made more resistant. But just in its natural state, heartwood is more resistant. All right, so let's look at different insects that cause damage to wood. Of course, most people know termites, and most of those have wings. They colonize shortly after. They dislike daylight, they like moist, they like dark, and they have several things that people that fight insects look for when they're looking for termite damage. Subterranean termites live in the soil, so they have to make passageways, and sometimes those some of the things that gives it away is they have passageways of mud that give up their existence. And non-subterranean termites are found in the southern part of the United States. They actually live in the wood itself. So there's you see the evidence of the holes. There's also tiny excrement pellets. That's poop. They eat wood, so they're gonna it's gonna look a little bit like sawdust. You can also look for shed wings in the late spring and early summer. Here's just a little map. I'm not sure if this is in your text or I pulled this from another reference, but you can see which parts of the United States are more susceptible to termite damage. We're in a moderate range, but if you get down in the southeastern part and all the way over into the eastern part of Texas, you can see they are at more of a high risk. And then here's a picture of them going, pretty good active colony of termites in a piece of wood. So they can do a lot of damage. And a lot of times, a termite's not to be confused with a winged ant. I squash both of those, just so you know. Tony, glad you could join us. You're going to squash both of those as well. But there are two different things there. So what do we do against insects? Mainly, once again, there is either a physical barrier or there's a chemical that is impregnated or penetrates into the wood, or you could even say a good coat of paint or a sealant or something like that would also help to preserve against insect type damage. Carpenter ants, which are large, relatively large as far as ants go, black ants, they dwell in wood, but they don't really eat it like some of the other insects do. And then if we cross over into what's called the marine borers, and really I don't know a whole lot about these, but mollusks and crustaceans that eat very rapidly, so more rapidly than termites. But once again, we don't really have a problem with that. They're more prevalent in salt water, so that's why they have to treat and protect piles for docks and things like that. And it used to be that even around here, like telephone poles, and they used a coal tar solution called creosote, but several years ago, they determined that that was not environmentally friendly. So there are other types of chemical treatments now. So there's a picture of a carpenter ant. And then one of these little boogers that is my nemesis is a carpenter bee. Most people confuse this with a bumblebee, but this close-up picture, you can really see the difference. They have a real shiny black body, more like a wasp or something like that, whereas a bumblebee is much fuzzier all over. I think I have a picture of a bumblebee. I'll go throw that up there. So you can see there's a lot more fuzz on a bumblebee. Most of you probably squash both of those as well, but a carpenter bee will bore very quickly, about a 1/2 inch hole, and then they turn into the wood and they'll go, left or right, and they can do considerable damage. But I got to tell you from experience, the problem with carpenter bees is not the bee itself. It's they lay their eggs and they have, their little larvae in there, and then the woodpeckers come and they'll actually peck through the wood, so the carpenter bee's gone back in to these, left or right. They can go several feet into the wood, so that the woodpeckers come in and they peck large holes to get to the larva. So that's a problem. And a carpenter bee can drill a hole in a matter of no time at all. So anyway, they're pretty destructive as far as wood goes. And then there's a picture. It's the only picture I could find of some type of marine borer damage. Just remember they eat relatively fast as well, relative to like a termite. All right, so the next one, that's insects and marine borers. The next one is just rot or fungus. So the main thing that you need to remember about wood rotting is it has to be the right environment, or you may say the wrong environment. So, there has to be moisture present. There has to be a temperature above 40 degrees. And just by your text or factual information, wood with a moisture content of 19% or less is not subject to rotting or decay. So, if you can keep it dry and ventilated, that's the main thing. So, most of the time when we have trouble with decaying wood, maybe it's because the roof is failing and some water is getting in and it's staying moist, so it's not ventilated, or there's obviously no sunshine getting there, so that's a problem. And for wood piles where we have an alternating wet and dry, something like that, that could be a problem. But they generally either treat those or they use different types of materials. So that's the thing with wood rot. So here's a picture of that. You can see the insulation. This looks like something that's obviously has a moisture content over 19%, so it can be a problem. So insects, marine borers, fungus, or you could say rot, wood decay, and the last one is fire. So obviously it's a major enemy of wood. However, if you just have a single log, and you've ever tried to imagine holding up a piece of wood and you have a lighter in your hand, it doesn't burn easily. It doesn't support combustion at all. It's the narrow openings and the imperfections. That's why people, that's why we split wood to burn it, is it burns so much better in those crevices. So that's something to think about when when you're considering fire for a design, is into the crevices of the wood. 2x4 would be the same way. It wouldn't want to burn easily. It wouldn't support combustion in and of itself, but in the crevices it would, or other things catching on fire. So, there's a couple of things. Mostly what we do in construction is we cover wood with gypsum board. Plaster used to be used, but now, and so that's sheetrock. So there are different types depending on your jurisdictions and your codes that you're working with. There are different types of protections, like you have a 1 hour fire rating, or a 2 hour, or 3. There's even a 4 hour fire rating, and typically that just means more gypsum. Now there's also caulks and sealants, mineral oils used, those kind of things to seal up openings. That's very difficult. You know, even if you have gypsum board or sheetrock coming up into another surface or whatever, you got to seal that crack, that transition up. So those are things like that that are used. And here's something good to kind of remember as far as it goes for fire, and this would be any design, really any material, is, you know, what's the most important thing is allowing enough time for occupants to escape. That's the whole concept behind, you know, a 2 hour fire rating, is a certain amount of time period that would allow the occupants to safely exit the building. So, you know, like I said, there's a few ways we do that. Wood can be impregnated with chemicals, okay? And so there is special wood. It's expensive. Like I said, gypsum is probably the cheapest thing that we can do. Fire retardant paints can be used. And then once again, you can see there on the bottom, the main concern is to allow enough time for occupants to escape the building. Let's look generally at the preservation of wood. I mean, most of the time you don't see any type of bark on wood that we use for type of construction. Obviously insects, and that would be a place for moisture to be, so it needs to be removed. You know, it used to be that, once again, they used creosote, and then they started using, and it's a long word, but it's why pressure treated wood, if you've ever, you know, seen that, it's kind of green. It's penylchlorophenol, and so they actually decided that it's not a very safe product either. Now I think they're still using that, because that's why they recommend that you not burn pressure treated lumber. People do, but it releases a harmful gas. So there are water-soluble salts that are injected in, and those are safer. But that's another way that we generally protect wood. I've already talked about creosote. There's different methods. I don't think you need to get into too deep about full cell method or empty cell method, but just remember that chemicals can be injected into the fibers of the wood itself that would enable it to resist even fire, insects, most of the things that we talked about. Paint, obviously, is something that will preserve wood. So enamel, varnish, sealers, all of those things are pretty easy. So if I were to ask on a test, you know, list 2 methods to preserve wood, you would have several options to go with there. All right, now we're going to turn over in the last couple sections here are kind of an interesting topic as far as construction goes. So, you know, if you just said, generally speaking, it's difficult for us to find wood that is relatively long and strong enough to support, let's just say, heavy loads. So they started several years ago, if you think about it, really, they started a process called glued laminated wood. And the most common glued laminated wood that most people are familiar with would just be plywood. And, you know, so it's wood veneer, and sometimes it's pieces or particles that are actually glued together, and it can be extremely strong. So this whole class here that we're going to look at are the different types, or at least some different types of glued laminated wood. So first of all, talk about what's called LVLs, laminated veneered lumber. These are beams, different type of rafters and joists and those kind of things that are glued together. A lot of people use these. You can see this picture over like garage doors for what they call headers. This is glued laminated lumber. Now this is just a picture of what I would call a paralam beam. It's a little bit different if I went back to it. This has laminates or veneers on the outside that are glued together, and I'll show you how that works in just a little bit. This one here is more like a particle, so a complete, like pieces that are put together and glued together. where you see these parallam beams, have you ever been into like sometimes like a Ryan's Steakhouse, and you look up and you'll see wood that almost looks speckled. Those are parallam type of beams, very strong. Now, one of the differences between LVLs and a parallam is a parallam really aesthetically looks good enough that you don't have to cover it, whereas an LVL, typically you don't leave those exposed. So you wrap them with something, or you're going to cover that with some kind of wall covering. So here's a picture of looks like a church, cathedral, or something like that, and so you can see. This kind of accentuates the problem that we would have. So if you were to try to do a heavy timber frame type of construction with this type of spans and with these type of loads, can you imagine the difficulty that you would have finding logs that you could cut that would be long enough and straight enough and even strong enough? Because remember, logs naturally have knots and discontinuities, which are weaknesses. So it would be very difficult for us to do this. Now, I'm not saying that they don't, but it's much more difficult to find. So this is a good slide that kind of captures the benefit of a glued laminated type of lumber. So by gluing the smaller pieces together, we can actually come up with something that is as long as we need it to be, you might say, and stronger, because what we're going to do is we're going to separate the discontinuities and the weaknesses. And so this is a really kind of a good list here. So weak spots are separated. If you have any unwanted character marks, you can hide those. End joints between jambs or the way they put the laminated number together, they're separated. If stronger wood pieces can be placed where the stresses are going to be the highest. And then, if you have, we can take those, so we hide the bad looking parts and we put the good looking parts out. So anyway, it's pretty neat concept. And this is, I may ask you to kind of redo this for me. So make sure you mark this slide. Now, by the way, this is, I don't know why they drew it showing negative bending. So, most of the time we show beams, I've been drawing those that smile, which would be positive bending. But it doesn't matter. You can still see the concept here that in just a single piece of lumber, so the load's coming up from the bottom, the tension in the extreme fibers would be on the top and the compression would be on the bottom. But if we do that in laminates or veneers on smaller pieces, then each piece would have a compression, tension, compression, tension, compression, tension. You can see that. So the magnitude of that stress in the extreme fibers is reduced. And so that's how laminated, that's how, kind of an illustration of how the stresses are distributed through laminated lumber versus just a true log or something like that. So it's pretty neat to think about. I mentioned plywood is probably the most common. It's been around a long time. So you have those veneers that are basically glued together. And one of the neat things, you can't really see it unless you pull a piece apart, but the veneers are actually running perpendicular to each other. So if you had a piece of plywood that had 5 layers, now you generally have a core on the inside, but you would have the outside running lengthwise, okay, say long, most plywood's 4x8, right? And then the next layer on the inside would be perpendicular. The grain would be running 90 degrees to the outside. So that's kind of how that works, and it increases strength in both directions. All right, very good. And that's just showing you the layers. If you actually look at plywood, that looks like a piece for furniture use, but you can kind of see how the different layers are banded together there. Soft plywood is generally what's used for construction. And it comes in different grades depending on, how many, you might say bad places are on it. C plugged is probably the most common that you'll find if you go to Lowe's or something like that. And I don't know if I can draw on that slide or not. Doesn't look like it. But C plugged would be like, if you ever see a piece of plywood that has like a football, like a it comes to a point and then around and then back to another point. That's where they had a knot or something. They cut it out and they plugged it in, and it is, you know, still a discontinuity, but that's how you could tell. See, plug. Grade A type plywoods are generally reserved for like furniture. And most people that are going to build furniture, they're going to use hardwood, which we'll talk about in just a second. But you can find different species. You know, mostly pine is what they use around here. Obviously, there's different glues. I'm not even sure where the closest plywood manufacturer would be, but probably comes from the Carolinas or somewhere like that. You know, we use plywoods also for making composite type of members. I think I've got a picture of those in a little bit, but they, you know, they can go ahead and prepare box beams or sandwich panels. For log home construction, there's plywood for roofing that actually has the insulation already adhered to it. So that's ready to go. A little bit expensive, but can be used. There's also coated plywood. So you can get marine grade plywood, which is, as we talked about before, it's impregnated with chemicals to help it last longer. That's like your pressure treated plywood, pretty expensive stuff, but it can be used. There's also a like a plastic type of coated plywood for you know, weathering, durability. I mentioned hardwood, mainly your hardwood. And I haven't priced hardwood plywood in a while, but you know, I could easily see that it would be $50 a sheet or something like that, a 4x8 sheet. So most of that is used for furniture or cabinet making, things like that. All right. I think this is the last little bit of slides here. We didn't have too much to do, but wood mechanical fasteners. So just so you know, I would probably ask you just to list, you know, according to your text or the lecture notes, what are a couple of mechanical fasteners for wood? Now that'll be easy. Most people ought to easily be able to say, well, a nail is one. So obviously that's right. And how does a nail work? Well, we drive it into the wood, and the friction between the metal and the wood hold the nail in, basically, or hold the two pieces together. And that's why they make nails with kind of a spiraling. They make nails with ribs on it so that the withdrawal strength is increased. And I'll show you a couple of different types of loading here. Let me go ahead and go to the picture if you can see that. Can you see that okay? Okay, good. So this is a pretty interesting picture. The way that wood grows, let's go to the worst case scenario is nailing into the end of a piece of wood. Now think about that. So you got a piece of wood, say it's a 2x4 or something like that, and you nail into the end. Would that be a good idea? No, that'd be a terrible idea. And so withdrawal from that would be kind of prying the other piece of wood out. That is actually not permitted in construction. And so, you know, a logical question may be, well, what if we kind of need to do that? Well, there are all kinds of fasteners, and we'll look at some in just a little bit, that are made to accommodate the different types of connections that you need. Now, a little bit better than that, but still not a whole lot better, is this lateral end grain. So you're not prying it out. You're kind of putting the nail in shear, but that one's not great either. The strongest load for wood is the lateral load in side grain. So we nail into the side of it, and then we pull and put the nail in shear rather than a prying or what's called a withdrawal from the wood. So in the withdrawal loading, the end grain withdrawal is half of the side grain withdrawal. So once again, it's not permitted in construction. And then you can see, as I mentioned, the most common and strongest loading is that side grain lateral right here. Lateral load and side grain is strongest. All right, next, how else can we put wood together? Well, we can put screws in there. So, you know, why are screws stronger than nails? Well, sometimes the actual metal, the screw, is stronger than nails. So that would make it stronger in shear. Once again, if we were trying to kind of pull that, it put the screw in shear, but it's also because of the threads. So that gives us more withdrawal strength. So remember, we're talking about really two types of loads when we put fasteners like nails and screws and bolts and lags, two types of loads. And since we're putting them in shear or withdrawal, that's why screws, once again, are sometimes a little stronger. The metal itself, which would improve the shear strength, and then the threads itself improves the withdrawal strength. All right, what about bolts? So we can have holes that are drilled in wooden members, and then we put a bolt in, and we tighten it up with a nut. And typically we use a washer. Well, why do we use a washer? And so we're talking about a little heavier construction here. So, we're moving up in the type of load that we need to resist. So bolts are typically larger. And when we tighten up a nut on the other side, the metal of the bolt is so much stronger really than the wood. And remember, wood's stronger parallel to the grain than it is perpendicular to the grain. So what we're going to do is we're actually going to just crush those wood fibers. So what do we use? Well, typically, you can see here on the bottom of this slide, typically we use washer, and that just helps us spread the load out of that the bolt is putting on the wood pieces that you're putting together. So it just spreads it out the best that it can. And then I think lastly here really is what we call a lag screw. I like to say that mama screw and daddy bolt had a baby, and what is it? It's a lag screw. That's for you, Tony. So we have the threads that increase the withdrawal strength, but then we also have the shaft, if you notice, the non-threaded part that really increase the shear strength here. And then, a major difference between a lag screw and like a bolt is obviously you wouldn't want this penetration to be entirely through the member. So this would still be hidden, but these are, pretty strong fastening type. Now, I mentioned there are lots of others, and the last two slides kind of show just some of these. But I'll tell you, if you go to the Simpson Strong Tie website, you would be utterly amazed at how many different types of fasteners that they have for almost any situation that you can think of. So here's a picture of some. Over here on the left, I think most of you have probably seen these, but those are just called joist hangers. So, it's a way to fasten, let's just say, two pieces of, I won't say boards, because we learned the other day the difference, of dimension lumber. Let's say like a 2x8 framing in perpendicular to a 2x10. How would you do that? So, would you try to toe nail it in? That would be angling the nails or screws from the side. Well, that's not a great way to do that. So they come up with things like these joist hangers. So once again, putting the fasteners in shear and withdrawal in a way that they are strongest. So those are pretty common. You see a little picture up here of how that works. Panel clips. A lot of times you'll see those in truss members, and so they'll drive those in. They have small perforations right here that are driven into the wood, a lot of them, and those keep those two members together. You don't see too many split rings or type of construction, but there is a fastener for any type of need that you have. They even make what's called lolly column caps. So if you have a steel, like for connecting steel and wood, that's obviously a problem because you can't fasten wood to steel directly. So how do you do that? Well, they make different types of fasteners that you would put and attach to the steel that then you could easily attach to the wood. All right, so nails, screws, bolts, lag screws, and then different types of connectors are all the different types of fasteners for wood. And I think that finishes us up for wood. There wasn't a lot of, trying to think, calculation type of problems in wood. There was this one here where we talked about the foot board or board foot, some people say. So you might make sure you know how to do that. But the rest of this was just material to study for the test. So remember, the next test will be the last test, and it will be on chapter 6 and 7. So this is wood, chapter 6, and then we'll start masonry on Monday. And so we'll finish that up all next week. All right, if you have any questions, by all means, let me know. Kristen, join us. So you ladies have a great day. It's supposed to be a beautiful day outside and a great weekend. Adios.